Welcome to a new exciting episode of our show, All Things Delivered. Today we are very excited to discuss with you a topic that is very current regarding cross-border supply chains, port congestion.
And how we're using the latest in technology innovations to solve the most complex business problems.
Technology innovation has never moved as fast as it is today, and it will never move this slow again. So now is the time to accelerate your supply chain transformation at the speed of AWS. Join us to explore the supply chain of the future today.
I'm Kimberly Haggerty, and joining me on this episode of All Things Delivered is my co-host, Michael Engardia.
In this episode, we are on the third leg of our supply chain journey, productive port operations, heavily intertwined with the digital analytics space. Our guest, VesselsValue, will show how data sets can be used in AI/ML applications to power the next generation of supply chain solutions.
So let's dive into the manifest with VesselsValue. Welcome, Ben and Adrian, to All Things Delivered. I'm really excited to spend some time with you guys today and learn a lot more about you both.
Thanks for having us, Michael. So my role at VesselsValue is I'm the CTO, and I'm ultimately responsible for the implementation and maintenance of all of our products and services and in-house systems.
Adrian, can you go ahead and introduce yourself, please?
I'm VesselsValue Chief Strategy Officer. That means I spend most of my time leading and managing our major new projects and initiatives, really from initial specification all the way through to commercialization. So VesselsValue, we were founded about 11, 12 years ago. So when we started, our mission, it still is our mission, is to make markets transparent. And actually, we were the first company in the world to bring an automated valuation model, providing daily updated values across each individual vessel in the global fleet. We then expanded that significantly by combining it with a lot of other data sets such as GIS, geographic information on ports and terminals and anchorages and jetties and so forth, along with a lot of proprietary behavioral algorithms that we developed in order to understand and predict what vessels are doing at any time.
I'm sure we can all agree when you put vessels and ports together, what's top of mind is port congestion and the impact that that's having globally on our economy and our customers. Can you tell me a little bit about the data insights that you're helping to generate for the customers?
Very, very timely question there, Kimberly. This is something that's been really at the forefront of a lot of our customers' thinking and analysis over the last 6 to 12 months. Congestion is part of the big system that is global maritime trade. And understanding and providing analytics, and specifically real-time or close to real-time analytics on global maritime trade, is really a big data problem. Once you have that, you can then start running different levels of aggregation. So potentially at the individual vessel level to gain operational intelligence, but then aggregating it up to really understand, the ins and outs and the details of global international trade.
And Ben, I'm guessing that when you have these events, whether that create congestion, like what happened at the Suez Canal and other things, you see lots of spikes in demand. Can you talk to me a little bit about all this data that comes in from, I guess, all the ships? And you mentioned billions of rows. That must be quite the ingestion process that you have. Talking a little bit about that initial ingestion mechanism would be interesting.
So our satellite providers have protocols that effectively stream the data over open sockets, and we have a server in AWS or a set of servers that their sole responsibility is to listen on those sockets to receive the messages and to safely, as you say, store them on S3. Once they're on S3, we then fire them through a pipeline which automatically goes through the process of cleansing them, decoding them, assigning to the right ships. We have some machine learning algorithms that look at whether it's legitimate data or not, and ultimately getting it into our database, which then triggers our real-time analytical servers to kick in and start.
It'd be interesting for me to understand a little bit about the simplification process as well as your presentation layer.
In 2012, we moved over to AWS because we knew we were going to store these huge volumes of positional data. And we set about using the RDS system as our master databases because it took away all the pain points of backups and scalability and all stuff that no developer ever wants to deal with, and hopefully you never need to deal with. Over time, when we took on the ADS data and also we've taken on additional satellite providers, we've almost quadrupled our data intake and historic data volumes. So we're actually moving over, keeping in the AWS space, we're actually moving over to using Snowflake to store that data, which stores it on AWS, on S3, and we've got our servers are close to that, so in the same availability zones, which means we're not charged for data transfer, and it's ultra quick. It's all about simplifying the data. Take the 20 billion rows and summarize it into 100,000 rows, and then summarize it into a 2-page report or an API that gives somebody what is happening in this very specific port or region or area or macro across the world.
We know that data across the maritime industry has been bad as long as I've been born. So what are we doing today to help compensate for the data integrity issues and the data challenges that we're experiencing?
I mean, we use a lot of different data sources, a lot of actually our own independently generated, but we do have to buy data in. Ben's been talking about our satellite and terrestrial AIS provider partners. And, one of the major issues with AIS is that it wasn't actually designed for tracking vessels. It was designed for anti-collision and anti-grounding. And it was only, some quite innovative companies that figured out they could effectively capture the signals from space and also from terrestrial-based stations. So this comes with a lot of problems, a lot of conflicting signals, a lot of poor signals. I mean, there's some quite interesting things that happen in terms of interference from certain defense systems of certain countries and so on. So there's a lot of poor data that has to be corrected, that there is data conflicts, there's gaps in the data. So it's critical because companies are making multi-million pound, almost billion-pound decisions basis this data. So the most important thing is reliable. And I talk about the process to do that, but also any data that has been fixed is so indicated within our system, so it has a different meta tag to it in order to indicate that it's not necessarily core data, it might be inferred data.
So Ben, as you're working with your architecture over time, and you're starting to evolve it, have you seen any trends that you're slowly starting to move towards, or any new technologies that have come out that you're looking to leverage?
Lots. So in the cloud server space, to give you an example, a couple of years ago, we were running regressions. So our core business is to value every vessel on the planet. And to do that, we're talking roughly 60,000 commercial vessels every day, every night. And to do that, we were running regressions for each of them. We were limited to roughly 30 or 40 of these regressions in parallel using traditional infrastructure. And when AWS launched AWS Lambda, we saw an opportunity if we engineered our processes to use Lambda and run 1,000 or even, I think the maximum is around 6,000 in parallel.
So if we look at this from a connection to data, a consumption of data, transformation of data, and then presentation of data standpoint, getting those actions to insights for the customers is really critical. What's next for VesselsValue in that area?
Simplification is absolutely key. This is this idea of taking billions of data points and trying to filter it down into potentially hundreds of thousands of data points, such as, vessel activity, their loading, discharging, congestion, and so on and so forth. But then also, and that can be used by our clients in their own internal systems, but then also actually filtering it down often just into quick pieces of information that our customers can make, very, very quick but critical decisions with. So yes, the visualization and the interpretation of this is absolutely key. And in terms of what's next, of course, we are continuously optimizing to make our data better. And it's very, very close to real time, but there's always, a kind of time versus data processing problem that goes on. And we are in the process of doing some quite major projects. The first one being identifying the actual cargoes on the vessels so that then we can, apart from doing the vessel trade and congestion and so forth, we can look at cargo-related and commodity and cargo-related congestion, trade flows, demand, and so on. So that's number one, identifying the cargoes. And number two is we've been expanding, and we have expanded into the aviation business. And part of that is processing ADS-B aircraft location data. And what we're incredibly excited about is combining our maritime vessel movements with our aircraft movements, and that's both passenger and freight across both. And if you have that, you pretty much have the majority of how the world moves its cargo and people internationally.
It'd be interesting to know a little bit about your API architecture and specifically kind of where you're going and where you've been.
An area where we're utilizing API a lot at the moment is we are taking some of our legacy data systems internally and turning them into microservices that are utilizing an API, and all of these microservices are running Docker containers, which means we can test them locally. All of the developer environments are identical to the production environments and the benefits that come with that.
Well, guys, it's been really fun. Thanks, Ben, for all the technical insights into your architecture.
And thank you, Adrian, for always being customer obsessed and customer focused. And thank you for joining us on this episode of All Things Delivered.
Thank you for having us.
We know that out there we have something like 64,000 ocean-going vessels, and each one of them is generating a huge amount of data. They're leaving behind a huge footprint. And this is only increasing in the future because you're going to have IoT sensors everywhere. So not only IS or GPS data, but also data generated from engines, auxiliaries, and electronics present on board. So what do you think would be the best architecture that we can deliver to manage this huge amount of data?
Really, cloud is where you can go. You want to be able to have that almost infinite infrastructure that you can go off and leverage, right? So you said huge footprints, that's large amounts of data. You want to be able to stream that data in, perhaps using like Kinesis, and store it in S3, and probably use things like EMR and other things to be able to manipulate that data and get it into some sort of, filter it, translate it, and be able to use it in different ways. I think you want to be able to do correlation, right? You want to be able to figure out how the data correlates to each other. And so I think we've got some cool ways to do that with, let's say, like Neptune and a few other things like that to be able to create those connections. And then, of course, we have enterprise search for being able to do semantic search, which I think there's opportunities in that area to be able to take a look at all the different kinds of data and try to figure out easy ways for people to be able to access it quickly.
Yeah, so all these services that you're mentioning are able to help us turning raw data into actionable insight.
The constraints that we have around the supply chain is nothing new. We've been experiencing this for decades. What is new, however, is the ability to have access to that data. So from a customer standpoint, you really want to be able to protect the customer and you want to be able to protect your financial bottom line. And at the end of the day, that's resiliency. So you want supply chain resiliency end-to-end across all the nodes, across the digital thread that you mentioned earlier, right? So it's having access to that data and it's having access to the right data at the right time across the right nodes and the right business leaders and providing that right action to insight availability of that data, because you really want the data to be at the point of use in order to be able to make those business decisions and to make those decisions that protect your customer.
And these articulates into an architecture where you have an ingestion layer, a storage layer, an analytical layer. And then you have an application layer where you can build on top a lot of cool things like API integration and machine learning and artificial intelligence.
A lot of times I think we've seen systems in supply chain that take in large amounts of data and then create alerts on it, for example, right? But if you create hundreds of thousands of alerts, well, that's sort of useless, right? So you really want to figure out how to instead detect conditions and then apply all those alerts against the same exact condition. And if you clear the condition, all the alerts associated with that condition go away. So I think it's higher level abstractions. I think as you get higher level, the machine learning comes in to be able to detect when a condition is active versus it no longer being active, and also to aggregate all the information that's associated with that condition back out.
So how do you help businesses to make the best of machine learning?
So when it comes to AI ML, what matters to the business is the ability to be predictive and prescriptive. and being predictive and prescriptive across all the different levels of the organization and levels of the business. You want to be predictive and prescriptive from a strategic level. You want to be from an enterprise level, from your supplier all the way to your customer, across all the nodes of your end-to-end value network. From an operational standpoint, whether it's regional, whether it's site, and then from a tactical standpoint, which is, the actual execution on the line as the activity is occurring.
So you have the technology challenge on one hand, storing data, processing data, and extracting value from this data. But then you have also the business point of view, so the change management across the organization. Very insightful and a lot of fun. Thank you so much. I would like to conclude with 3 key takeaways. The first one, we learn how ocean transportation is a critical piece of the puzzle of your global supply chain. The second is that today you have products brought to the market by companies like VesselsValue that are enabling you to get better insight, better control, and better visibility on your ocean transportation. And the third is that behind the scenes of such products, you need to have the right technology that needs to be scalable, needs to be flexible, and needs to be cost-effective to deliver insight at scale. And cloud computing is the answer. We look forward to have you with us during the next episode of All Things Delivered.